Hello, everyone, and welcome to today's SANS webcast, Breaking Bad Bots, the new #1 threat and how to stop them, sponsored by Cequence Security. My name is Carol Auth of the SANS Institute. Today's featured speakers are Shreyans Mehta, CTO and co-founder, and Franklin Jones, CM, both of Cequence Security, and Franklin will be moderating today's webcast. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Franklin.
Thank you, Carol, and welcome everybody. Thanks for taking the time to join us today. We've allocated about an hour, but we're probably going to have be done before that, so we'll give you a little time rebate at the end if all goes well. But basically what Shreyans and I want to do today is share with you what it really is emerging as the new #1 cyber threat facing hyper-connected organizations. And it's one of those threats that tends to fly under the radar because it's much different than the kind of threats most security teams are familiar with. So what we're going to do today is I'm going to spend a few minutes just going through a little bit of background on these threats and why they happen, how they happen, and so forth, and then talk a little bit about the Cequence approach to solving the problem, and then hand it off to Shreyans, who's going to present a live demo that will go into more detail on some of these topics that we're going to be covering today. So apologies in advance because some of you may be experts in bot attacks, but we've noticed in our conversations with customers is that there's also a lot of customers that just are completely unaware of this. So we're going to start from that position of some education, some background on that topic as well. So with that, next slide, please. So it is really emerging as the new #1 cyber threat. There's been some research published over the last couple of years that has shown growth in this particular attack vector, where today it's arguably somewhere between 30 and 33% of all internet traffic. And I think about that. And this does not even include the good bots like Google and Kayak and applications like that use bots to gather information from a lot of different sources. This is just malicious bots. And it's accounting for a third of all internet traffic. But what's interesting is we've noticed from our own customers that when they are attacked, they will see spikes where 90% or more of all the traffic on their network happens to be malicious bots during that attack period. So the questions are, why does this happen? What do they want? And how can we stop them? And that's what we're going to look at today. Next slide, please. So it's a three-phase process that these attacks go through. And it starts, ironically enough, with the data breaches that tend to get all of the headlines. And not to throw Marriott under the bus, but that's a great example I think we're all aware of, a breach that occurred not too long ago where originally they thought about 500 million records were stolen, but in the end I think they figured out it was closer to 400 million, which is still a lot, a huge amount. And that's not the only breach, obviously. So what you're looking at here is a screenshot I took last week from a website called Breach Level Index, really cool site. And they update this information continuously. And so during the time I did the screen capture, it shows that more than 6 million records every day were being stolen, 72 records per second. And even during the time I've been speaking here, more than 5,000 records. So it's a chronic, ongoing problem. And like I said, these are the breaches that tend to get all the headlines. And then after, a few days, a week or two, the headlines die away and people forget about it. So the question is, so what happens to those 300 or 400 million records that were stolen? Well, unfortunately, they end up very often on the dark web. Next slide, please. So what happens is, then the bad actors step in, and what they will do then is go on to the dark web and look for these credentials, and they're very affordable actually. But you can't perform an automated bot attack without these credentials. And typically, in this particular scenario that we're going to walk through today, we're really talking about username and password combinations, right? So the bad guys figure that if this username and password works on the Marriott side, hey, let's try it on website A, B, C, D, and E, and they're probably going to work there as well, or at least in one or two of those sites, because people tend to reuse the same passwords and login credentials over and over again. So that's step one, is getting those credentials on the dark web, and again, very affordable. Then, of course, they need the tools to build their attack strategy. What is it that they're trying to achieve? How can they structure this attack in a way to make them less detectable? And then, of course, they need the infrastructure, because they don't want to appear to have this attack coming from one location. Ideally, it looks to be a global geo-distributed attack, so it's very hard to figure out where the source of the problem is. So those are the three requirements: credentials, tools, and infrastructure. And once they have that in place, they're ready to move to phase 3. Next slide, which is where they launch the attack. So in this particular slide, what we're looking at is on the left side is basically one guy launching a geo-distributed attack from what appears to be multiple locations around the world, all targeting what we call hyper-connected organizations. And this is really, more and more organizations today are hyper-connected. And by that, we mean that they rely on the internet to connect and do business with in a secure way, with customers, with partners, with suppliers. And in order to do that, of course, they have externally facing web applications, mobile applications, API services, all of which are designed to connect, again, with customers, partners, and suppliers, and really create a user experience that's positive for everybody, conduct business in a way that allows them to have benefits in terms of the supply chain and so forth. So the bad guys want access to those applications, and so they're using these login credentials. In this case, again, the scenario we're going to be talking about today is primarily targeting web applications as an example. However, they're also targeting mobile applications and these API channels. And the reason all three of those channels are important is if they can get access to internal data by compromising the login credentials from those different channels, then they can gain access to different functions inside the business and to perform financial fraud, ruin business reputation, etc. And the problem is legacy security tools, and here's why this flies under the radar a lot. Legacy security tools are typically unable to detect and defend against these types of attacks, and we'll talk about that in just a minute. Next slide, please. So what is it they want? So there's lots of different attack objectives here, but again, in this particular scenario today, we're going to focus on account takeover. But as you can see here, there's a lot of different objectives that these guys have. And by the way, the different attack objectives you see here came out of research we did not too long ago, where we talked to about 211 organizations, large organizations across the U.S., and wanted to know, are you guys a target for these kind of attacks? And if so, what kinds of attacks are you seeing, and what do you see as their objectives? And this is what they came back with. And account takeover was top of the list, of course, because that's sort of the starting point to do a lot of these other tasks. So next slide, please. So the question is, so why is it that traditional security tools can't really effectively deal with this kind of attack? Well, let's start with CDNs. CDNs are great. A lot of these large organizations, maybe yourselves included, use CDNs as a way to accelerate delivery of content to really enhance and optimize the experience for end users that want to do business with you or get access to different information on your website. So they're perfect for that. So one school of thought, it's already there, so let's inject or integrate security functions within the CDN to deal with this problem. But again, the problem here is CDNs sit inline, so in terms of making decisions around security issues, their ability to make a decision is limited by the balance to deliver optimal performance without introducing latency. So the decision has to be made pretty quickly, almost instantaneously. And in this case, this kind of attack requires a little bit more insight and analysis. And so inline detection is a non-starter here, because it's really going to introduce latency without really solving the problem. And the other problem with CDNs is that they were never designed for security, although having said that, a number of CDN vendors are trying to add security functions to address different kinds of problems like this. But in the end, they can't protect all these channels. They can't protect mobile, web, and API effectively. So there's a number of reasons why CDNs are not a good solution to the problem. WAF, Web Application Firewall Appliances, seem like a logical place to solve the problem. They're already there. They're widely deployed. But again, they're inline, and they were not designed to do this kind of security. Because they're inline, same problem as CDN. They have to make a decision fairly quickly. Yes, no, block, allow. Is it good? Is it bad? And the way they do that is typically they're looking for known bad, and they're applying signatures once they recognize known bad to block that, typically related to application vulnerabilities, as you know. And there's really no insight that they provide into the underlying intent or behavior of the application transaction between the client and the server. And that's really the key here, is understanding that intent, that behavior that's behind all of this. And that's something CDNs and WAF appliances simply don't do well. The good news is, over the past couple of years, we've seen the introduction of purpose-built tools designed specifically for bot defense. And we characterize them as first-generation bot management tools. So definitely a step forward. But there's problems with those tools as well. The first problem is that they do not have the ability to discover the applications on your network. So why is that a problem? Well, if you're on the security team, you know that you always run the risk of shadow IT or line of business managers rolling out their own stuff without ever working with security teams to make sure that the security aspects of the deployment are properly implemented. So oftentimes you won't even know that those applications exist. So how can you defend against attacks on those applications if you don't know they're there? And this is the problem with these first generation bot management tools, is they will not tell you what applications are out there. All they'll say is, point me to the applications you want to protect, and we'll do our best to protect them. So, there's that issue. The second thing is, once you decide which applications you want that kind of tool to protect, then you have to do, or assign somebody to do a modification to those applications. And that involves inserting JavaScript to determine whether the web browser is an authentic web browser, or is it, an automated fraudulent browser, so to speak. So JavaScript can help you do that, but that's modifying every web application to get that data back from the client. Mobile application, same thing. You have to use SDK to modify every mobile application to essentially get the same insight from the client. Those are time-consuming tasks. In fact, one of our customers had a person prior to deploying Cequence, had a person that was devoted to that task almost full-time, which is a ridiculously inefficient use of skilled personnel. Even after all that, these first-generation bot management tools are unable to effectively protect all of these channels, mobile, web, and API. So although it was a step forward, certainly not where you need to be in terms of the protection against these automated bot attacks. Next slide, please. So that segues to the introduction to the Cequence Security application security platform. So this is an award-winning, patented, AI-powered platform we're very proud of. It is a software platform, first and foremost. So there's no specialized appliances, no black boxes. It's very scalable, designed to be open, container-based. So it's very rapidly deployed on premises in the cloud, any number of locations, regardless of how it's deployed. It can all be managed as one single integrated system. Now the platform, because it's a platform, it will be designed to support a number of different application security services. But for today, we're going to talk about one of them, and I'll just get to that in a minute. But within the platform itself, there are three key capabilities that all of the services above will tap into and leverage. Next slide. The key foundation of this is what we call the CQAI engine. And the CQAI engine is the patented technology, the secret sauce, if you will, that allows us to detect these kinds of malicious bot attacks. So it basically takes a copy of the traffic flowing through the network. It is not inline, and it goes through a deep dive analysis using machine learning, behavioral analysis, and other AI-powered technologies to figure out very quickly what the profile of this traffic is, and we'll see examples of that in Shreyan's demo here. But it performs this continuous multi-dimensional intent-based detection, which is really important because, again, there's no malicious content here. We're talking about understanding the underlying intents and behavior of these transactions. Next slide, please. So within seconds, the CQ AI engine does its thing and then hands it off the results to the CQ Manager, which is the management platform you would use to really get visibility into what's going on in the network. So the first thing it does, of course, is when you fire it up, you'll see that it discovers all the applications on your network. Well, that's a great start. So now you can figure out where are the targets and how do you want to protect those. So the attack data is continuously updated on these targeted applications, and as you drill down into it, and you'll see this in the demo, you'll start to see insight into the source, the target, and intent of these attacks on your organization. Next slide. The third component of the platform, which is actually really important, is what we call CQ Connect. And because this is an open API platform, what it allows you to do is share information with the other tools in your security architecture that you want to share with, and in order to support your internal workflows, optimize your processes, and really get the most out of your staff. Because if you have products operating in isolation, that's not going to help you get the bigger picture of how to manage your overall security infrastructure and architecture. So we built this with this CQ Connect function to make it easy to connect with the other devices in your network. You can even use it to perform automated mitigation through your existing WAF, for example, if you choose to have that remain in line. Next slide, please. Now, on top of this, and this is the focus for today in the demo you're going to see from Cequence, is what we call CQ Bot Defense, which is a security service module that plugs into this platform and really leverages the three key components that I described underneath, the components that deliver the intelligence, the insight, and the integration. So CQ Bot Defense was purpose-built to really gain insight into these attacks on your web, your mobile, and your API applications. The good news here is there's zero modification required to any of your applications. So that means no JavaScript, using SDKs to modify mobile applications. So you're up and running with this very quickly. And because we also provide multiple mitigation policies, it gives you flexibility there. So, for example, if you see an attack, you could decide, I'm just blocking it. You could rate limits to frustrate the attacker, or you can apply some detection techniques to make them think that they've succeeded when, in fact, they have not. So we're trying to design a lot of flexibility into the solution so that you can decide how best you want to use it to protect your organization. Next slide. In terms of deployment, so here's the struggle with creating this kind of a diagram. This platform is so flexible, it can be deployed in a number of different ways. So it's hard to show one slide that says, here's how it's deployed. But here's an example of how you could deploy it. So on the left, again, you've got this bad guy. You've got this orchestrated attack that appears to be geo-distributed with all of these application requests using stolen credentials coming in through the firewall. And then basically what we do, the dotted blue line there coming off the load balancer, is we take a copy of that traffic, run it through the CQ AI engine, do that multidimensional analysis I mentioned using the AI-powered machine learning behavioral analysis, and quickly come to a verdict and a risk score and risk confidence level, along with a lot of detail on what has been identified as a malicious bot attack. That's presented to the CQ Manager, as shown at the bottom of the screen, and then you can make decisions there, again, in terms of how you want to mitigate that. So while the bad guys on the left are trying to ultimately reach the application tier on the right, CQ Bot Defense is a component that can sit in line, or you can use your existing WAF, as I mentioned, to automatically mitigate this attack and stop it before it has a chance to achieve its objectives. So like I said, this is a very flexible deployment. So if you're curious about will it work with, the specific scenarios in your organization, that's a separate discussion. But the answer is probably going to be yes, because it's of the flexibility of the architecture of the solution. Next slide, please. So I'll skip over this. I won't spend much time on this because Shreyan's demo will get into this a little bit. But here's just an example of the CQ Manager application and what you might see. So on the left, in the lower left there, I'm not sure if you can see that clearly, but basically you see this blue bar going across and then a red bar across the top of that. So the blue bar basically represents known good traffic. The red bar would indicate suspiciously likely malicious bot traffic. And here it looks like almost like a 50-50 split, but I mentioned in some cases our customers have seen 90% or more of all traffic being malicious bot traffic. So if you want to drill down on that, then on the right-hand side, you can drill down and see more details on the source, the target, the intent, and so forth. But again, Shreyans will go through this in more detail in just a moment. Next slide, please. And the obvious question now is, okay, this all sounds good, but does it really work? So the Cequence solution has been deployed in a number of large organizations. This is a quote from one of our Fortune 500 customers, an online retailer. And they said the Cequence solution paid for itself just by detecting and preventing a major bot attack over a recent holiday weekend. That definitely would have brought us to our knees and significantly impacted holiday revenues. So what's interesting about this quote is that, as they highlighted, it was a holiday weekend. So this, you got to give the bad guys credit here, because the bad actors targeted this site on a holiday weekend for two reasons. One, the company would likely expect a spike in their web traffic during a holiday weekend, because they probably had some promotion going on, which makes total sense. The other thing that's going on a holiday weekend is people are taking off. So maybe staff is lighter than it normally is. So again, perfect time to target that kind of an organization with a malicious bot attack. So these guys are smart. They know what they're doing. But again, in this case, even though they had a lean staff, the Cequence solution was up and running and identified and stopped the attack before it had a chance to succeed. And like the company said, it paid for itself. Next slide, please. So a quick summary of 10 ways Cequence delivers value, and I've touched on all of these, but these are actually unique differentiators, because this is a huge problem, as I mentioned. It's only getting worse. So as you consider your options for defending against these, consider these values, okay? First of all, software solution, no appliances, which is great, which means you have flexible deployment options. It's very likely going to work with whatever security architecture you currently have. There's no inline detection, so you got a little bit more time to figure out exactly what's going on, which inline products are unable to do. The application discovery capability means a huge time saver right there. Because you understand what the targets are for these malicious bots. Again, time saving with no JavaScript or SDK intervention required. You've got this AI-powered platform with the intelligence to quickly identify what the core problem is, and then bot attack defense, applying mitigation techniques against that, and they could be automated as well. And the open architecture works with anything you have or everything you want to integrate with, all of which collectively deliver, in addition to all of that, this economic value, because it can help you reduce infrastructure costs, for example, because you don't have to upgrade your infrastructure thinking, oh, we've got a lot more traffic than we expected, we better increase our server capacity, etc. And there's no risk of financial loss, business disruption, or damage to reputation. So lots of benefits there. Next slide. Now, before I hand it off to Shreyans for the demo, in case you're not familiar with Cequence Security, we are the classic Silicon Valley startup, privately held, venture-backed, based in Sunnyvale, California. The leadership, half of us came from Palo Alto Networks, spent many years there, and half from Symantec. And Shreyans was from Symantec, for example. And so collectively, we've sort of been there, done that, and have the expertise to take this to the next level. So we're excited about building this set of integrated, innovative application security solutions in a platform that allow you to deploy it in a way that makes sense in your organization and add the capabilities you want within that platform to address the security requirements you're most concerned about. Gartner named us a cool vendor last year, so that was kind of cool. So with that, I'm going to hand it off to Shreyans, who is going to show you a demo of a lot of what we've been talking about.
Thanks, Franklin. So let's pick up from the story that you spoke about, right? Account takeover activity. And I'll go through a news here. So, and things like this happen very, very often. So like this one from SC Magazine, where this happened on, at least the news came out on Jan 10th earlier this year. Credential stuffing attack prompts Reddit to force password resets. So this is a typical case of an account takeover and credential checking activity, which led to Reddit users being impacted. And what it really means was somebody was actually trying to use previously stolen credentials, not necessarily from Reddit, but got it from someplace else and tried it over there. And most users tend to reuse the same username passwords across various sites. And the goal of the bad actor is, even if it gets, let's say, 1% hit, 0.1% hit on those credentials, those are money to these guys, right? They can then actually try to do a fraud with those verified credentials, reselling them in the black market, whatever that might be. And as you see, Reddit was hugely impacted by this. So let's do a little bit of role playing here. The first phase is I'm going to act like a bad guy who will try to access stolen credentials from the wild and then try to attack a site that we have set up here. So my first goal is to get access to these stolen credentials, right? I can actually try to attack a site and get access to those credentials. There are a couple of ways you can do that. One is go to Shodan, look for open database servers. These days, it's not just about your SQL servers, but the new generation database servers like Elasticsearch, MongoDB. All these guys are most of the times people sort of forget to lock them down, readily available. You can go ahead and access that. But I'm going to choose an easier route. So there are a bunch of bots that are available out there, and some of them are posting these credential dumps on Twitter and various other black market forums. So like this particular one, Check My Dump, I mean, it's constantly scraping the dark web and then looking for stolen credentials. So like this one, I'm going to click here. I have a bunch of email addresses. Looks like these accounts are from Spotify, so that's great. But I could even try them out. Like this is Gmail, Hotmail. So the likelihood that these users are using the same usernames and passwords on other places is very, very high. So I can try to attack the site that I want. But this is so easy, right? I mean, I can get access to credentials like this, like yet another 180 credentials, again, Gmail, live.com, and you name it. So it gets, and there are a bunch of sites like these that get me access to these credentials. And then think about the bigger breaches, things like Yahoo, LinkedIn, Dropbox. And so those guys have actually reset their passwords, but the likelihood that the users would have reset the same username passwords on other potential sites that they're using the same credentials is very, very low. So that's the way I'm going to reach out and try to hit on some other site. So now I have access to these credentials. The next thing I want to do is, instead of hitting a site from just one IP address, I want to distribute my attack, because I have access to these hundreds and thousands of usernames and passwords. And if I try it from the same IP address, the likelihood that a typical WAF is going to catch it is high, because they can do simple statistical counting. They're okay, 5 requests a minute from an IP address, go ahead and block it, maybe a bot, right? So instead, what I'm going to do is, maybe if I've decided to attack a business in US, so let me get access to a bunch of IPs from US itself. So very easy to get a list of open proxies that are out there. I mean, there are similar sites available. Just download these IP addresses. You can even filter them out based on countries, so wherever you want to hit from. And there are probably hundreds of such sites available where you can you write your own bot, scrape the content for the IP addresses, and that gives me an army of IP addresses to hit from. Okay, so the second job is done. I have an access to infrastructure that I can use to attack. Now, the third aspect is the tool, right? So I'm going to give you a demo of a well-known tool from the black market called Sentry MBA. But there are a bunch of tools like these available. Sniper is another one. You can write your own tool using Perl, Python, or language of your choice, or drive a real browser. You can drive Chrome headless, you can use Phantom JS, whatever you like, but the intent is the same. So let's go in. Here, I'm going to show you a tool called Sentry MBA, which can put together the things that I've collected and write a configuration to attack a site. Let's say in this case, shop.emadisonisland.com. It's an e-commerce site, and I want to attack its login page. So what I can do is I can load up the proxy lists that I've collected over here. I can load up the combo list of usernames and passwords that I want to try out, and then even configure how I actually want to attack. So what I want to do is, instead of making it look like I'm coming from just one user agent string that signifies what browser I'm coming from, I want to rotate through the username, the user agent list, and even configure the flow of the attack, in the sense that I want to go to the home page first, fetch the cookie, use that cookie to then go to the login page, and then try out the username, different usernames and passwords. So you can create your entire flow here, and things like Sniper, you can configure it for not just for your website, but maybe your mobile flow that works on JSON, or an API that is using XML. So it doesn't really matter, but you can create that entire flow here, and then rotate through the IP addresses and rotate through the username, passwords, and any hit that you get, it's money to you guys. So that's the attacker profile. So in this case, I'm going to attack a site called shop.emadisonisland.com. I can even use a simple Tor exit node to do that, right? And then maybe even distribute it upon multiple Tor exit nodes. So that's my attacker view. Now let's go back to, let's change my role a little bit. I'm going to act like a defender on of the shop eMadison Island site, and in this case I've deployed the Cequence application security platform. So let's figure out what I see on the other side. So what you're seeing here is the dashboard of our product. Now, as security personnel, my first job is to understand what is my attack surface like. So the first thing I want to see is what are the open endpoints on my different properties that I might be hosting. In this case, this is Shop eMadison Island, and this tool actually automatically discovered that I have two entry points. One is a login post, and the second one is a new account creation flow. And there might be others as well, but these are the ones that are discovered. If you have a much larger site, or you're hosting multiple sites, they all start getting populated here over time, and then you have an actual view of what are my assets. And if your developers are rolling out new applications, you will see it here. If you think that there are certain applications that are deprecated but they're still being used, they will all show up here. So that gives you a starting point on what your attack surface and what you should be protecting. Then comes into the detection phase around, okay, what's actually happening on my site. So looks like I'm being attacked. About, I would say, 27% of the traffic here is coming from bad bots, and like Franklin mentioned earlier, in most customer environments actually ranges from 60 to 90% for certain applications and flows. You can zoom in, zoom out to the application level, what the traffic looks like, but you really want to dig into details on what's actually happening behind the scenes. So as Franklin mentioned earlier, our CQ AI engine looks at transactions as they are coming in. but in a sort of a non-intrusive and non-inline fashion. And we're not looking at just those transactions by itself, but we're looking at how many similar transactions have I seen in the last 1 minute, last hour, last day. And because ultimately, when the bad guys started that attack tool, they're not just coming in sort of fast and furious. They're sometimes coming in low and slow. They're distributing that attack, right? So you want to see those transactions in a clustered way, so that you can make a better judgment. Okay, what kind of is this human or an automation coming in, and then what is the real intent on top? So what we do is, for every transaction that comes in, we create a fingerprint of that transaction, right? Okay, independent of where they're coming from and what user agent that they're using, right? That way we can cluster them together, and these are the clusters that got created. So in this case, we see two kinds of tools that are hitting. We have a confidence score, just similar to like a fraud system. We in a way, what we're trying to do here is more like a pre-fraud that ultimately leads to fraud. So you have a very high confidence score in this cluster. We have 3,500 different transactions that have hit here, and they're coming from 27 different IP addresses. But all these transactions look very, very similar. And this is the details around that cluster that just got created. So what you see again, traffic coming in from 27 different IP addresses, 19 different organizations, and hitting from various different places across the globe. And it looks like the traffic is coming from 5 different user agent strings. Like I said earlier, and I can show you the details around those user agent strings here quickly. So somebody is rotating through i7, i10. In this case, it's Chrome 47, Chrome 41, Firefox 40. So they're trying to fake the various different browsers that are out there. But our machine learned model, Popov here, is saying it's not behaving like the browser it claims to be. So that's odd to begin with. Now, what we are also seeing as a behavior is we're seeing a bunch of failed logins and somebody using credentials from Dropbox and Yahoo in here. So that's really, really odd, right? So I got a hit on what kind of credentials are being used, and then I'm Shopee Madison. I don't, so I'm not really Dropbox or Yahoo. So somebody using credentials from there is really, really odd. And so we saw this kind of activity, and we are seeing this activity not just at the IP level, but at an organization level. What that means is maybe somebody's trying to stay low and slow, but maybe switching the IP addresses every once in a while, but staying on the same network. So we see that kind of activity here as well. And then there are a bunch of other hits that we saw that, okay, things are coming in from Tor exit nodes, things are coming in from hosting providers. I'm a retail site, and traffic coming in from these places is really, really odd for me. And there are a bunch of other triggers in here, but I'm going to stay at high level. And you can even get visibility into what users got tried, and if they're compromised users, you can get visibility into that, and then even potentially export into other systems if need be. So at this point, we've detected that there is an account takeover activity happening here, account verification type of activity happening here. You have two choices moving forward. You can take the data that is coming out of the system and then build policies to export this data into other systems. You might have a WAF in place. You want to push this data all the way up to your perimeter. Maybe you're using a CDN, a WAF over there. You can use that, and you can use policies, take policy-based actions over there. Or if you have our mitigation in place, you can decide to use to implement policies on the box itself. So we provide you with the range of capabilities, as Franklin spoke about. where you might want to go ahead and block if it's impacting your back sort of upstream applications, because you've the bot attacks are significantly impacting them, potentially even leading to application layer DDoS. Uh, Sometimes you might want to rate limit them, because even though it's automation, it might be gray automation, it might be some sort of aggregator scraping your site, but it's coming in at an odd time of day where your human traffic is also high. So you might want to rate limit them. You can, but if you identify that it's an account takeover or account verification activity, you want to actually slow them down by not simply blocking, because blocking tips these guys off, right? And they'll come back from a different IP address, maybe retool, whatever, because they just know that this way of attacking isn't working. So what we can do is we can actually send them fake responses, and where the tool continues to think that the attack is going through versus traffic is really never hitting on the backend servers. And then there are a range of other options. You can sort of signal the upstream application that okay, I've identified something is bad, but your upstream application can take actions combining it with maybe potentially a fraud system. So that the platform nature of the product allows it to sort of integrate with other systems that you might have to sort of create a 1 + 1 = 3 kind of effect over here. So again, so we covered the three aspects where we discovered the applications, we detected the abuse, and using policies, you can take range of different actions. So that's sort of the high-level view of the system itself. And we do this without changing your application or asking you to integrate any sort of SDKs, and we work across all channels, be it your web application, be it your mobile or APIs that you're exposing to your customers and even your partners. So with that, I'll wrap up the demo and give it back to Franklin.
Thanks, Shreyans. That was great. There were a few questions that have come in. Probably won't get to all of them, but there's a handful here we should touch on. One, Shreyans, is how do we handle encrypted traffic?
So there are a couple of ways we can handle encrypted traffic. Number one is we can passively decrypt the traffic ourselves, as long as you load up the certs and keys onto our product. Now, be aware that this product is actually running in your environment. That means you are in control of the product as well as the certificates and keys. So that is one way we could deal with it. That approach works if you do not have perfect forward secrecy enabled. The second approach that we take to deal with encrypted traffic is you can potentially even send us decrypted traffic. So let's say your SSL termination is happening at your load balancer layer. You can send us traffic from there. We can be deployed as plugins into your load balancer environment. So we are not even in the business of dealing with sort of encrypted traffic. We get the traffic directly off of your Nginx or other environments that you might have.
Okay, cool. And talk about capacity to handle attacks.
So, as Franklin mentioned earlier, our entire stack runs inside Docker containers with the ability to just scale out horizontally. So we are deployed in environments that are large financial institutions, retailers, social networks, and sometimes we are even handling up to 26 Gbps of traffic. So it's actually natively designed to work in very large scale environments.
Okay, and one question I could probably answer is this targeted to large enterprise, or is it useful for SMB as well? Honestly, most of our deployments at this point are large enterprise, which is by intent, because we want to make sure that we're delivering a solution that can scale to deal with huge amounts of traffic. And I think Shreyans covered that in some depth there. But in terms of SMB, I think the answer is going to be yes. Today we don't have many deployed in that segment, but that's probably a topic we should take offline. So the person who had that question, maybe if you want to follow up offline, we can go into more detail with you on that one. Next question is, how long does it take for the analytics engine to determine whether traffic is malicious or not?
Yeah, so the way our technology works is we have a concept of votes. And there are some votes that come in, or sort of the engine starts working immediately the moment we start seeing traffic. And so you get immediate value the moment things get plugged in and the system is configured. Over a period of time, you're going to see increased efficacy, because when we start learning your local applications, what do they look like, what the normal human pattern is on the site, how do your mobile applications behave, you will see improved efficacy over time. And it's a continuous cycle of discovering applications, understanding them, detecting them. But you will see immediate value the moment you turn on our product and configure it.
All right, cool. And then last question here is, and you may have covered this already, but talk about the deception technique specifically.
So our deception technique, what we call is the honey trap, the idea really is it actually morphs itself into any application that you want to make it act like. So you could have a mobile application that is serving JSON. It could be distributed and serving local content based on languages, and behaving in a certain way. Because we are looking at all the traffic that is coming in and sort of zoom into individual application traffic, we can respond in a way the application looks like. So you can scale it up to maybe tens and even hundreds of applications that you might have. And the idea really is you can respond with what a successful login might look like. You can respond more like a password reset flow, even respond more like a new account creation flow. It's really up to you how you want to use it.
Okay, thanks, Shreyansh. Okay, I'm going to hand it back to Carol, but one last thing. If you want to learn more about Cequence, I forgot on the slide here, we didn't include our website, which is cequence.ai. So I encourage you to go there and spend some time learning more about what we do. And if we can help you, please contact us. So with that, I'll hand it back to Carol.
All right, well, thank you so much, Shreyansh and Franklin, for your great presentation, and to Cequence Security for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.